All right, we're going to start looking at absolute value equations, but first let's do a little review of absolute value. Absolute value, I'm going to take whatever is in the absolute value signs and make it positive. The absolute value of negative 100 is 100, absolute value of 1,000 is 1,000, the absolute value of 100 is 100, etc. So if I said what the absolute value of what is 1, well, or in algebra, the absolute value of x is 1, you tell me, oh, well, x could either be 1 or x could be negative 1, because if I plug those in there, the absolute value of that will be 1. So similarly, absolute value of x, I could say x is 5 or negative 5. And let's look at this a little bit more graphically. This is the same as absolute value of x equals 5 if I do absolute value of x minus 0. That is the distance from x to 0, and equals as always is, and then 5. So the distance from x to 0 is 5. If I put this on a number line, I'll go ahead and draw a number line and put in my 0. I'm going to measure 5 units to the right, and then I'll measure 5 units to the left, and I get to numbers 5 and negative 5. So if I can write that algebraically, if I have the absolute value of x equals negative 5 or 5 or negative 5, same thing. And I can sort of split that up and show that algebraically down here. Let's do one more where we're actually looking at the absolute value of x minus 3 equals 5. This is the distance from x to 3 as 5 units. Okay, so if I graph that on a number line, I'm going to plot 3. Once I get 3 plotted, then I will plot 5 units to the right and 5 units to the left. 5 units to the right is 8, and 5 units to the left is negative 2. So the answers are negative 2 and 8. That's the values of x that I can plug in there, and that will make the absolute value of x minus 3, 5. So you can see if I split this up algebraically, again, I'll make x minus 3 equal to 5, x minus 3 equal to negative 5, and I can show that it's equal to 8 and negative 2. Order doesn't matter, and set parentheses. All right, let's see a couple more here. So next one we have, well, actually, first, before we move on, this is just generalizing, and your textbook video generalizes this, and I just wanted to show you the sort of, if you have the absolute value of x equals a, so a is just some positive constant, then we can say, okay, x will be a or negative a, and those are your solutions. So doing a couple more actual examples here. If I have something like 2x plus 8 minus 3x, and that's all inside the absolute value, I can put the x's or constants together. And then I split it up and make it equal to 6 and negative 6. All right, so I solve here and I get x equals 2 and x equals 14. And again, I'll just put that in set notation, x equals 2, 14. Notice on this next one coming up here that we don't have everything inside the absolute value here. We have plus 7 on the outside, so I had to isolate x minus 3 first. Then I set it equal to 5 and negative 5, and I solve, and I get x equals 8 and x equals negative 2. One last one here. If I have the absolute value of x minus 3 plus 2 equals negative 6, I go, okay, I still want to isolate the absolute value, so I'm going to subtract 2. But if you notice here, I get a negative 8 on the right side. I got to stop here and think, wait a second, absolute value always equals a positive number. It cannot be equal to a negative number, and therefore, in this case, there is no solution.